Good day. So this is another type of pattern that we can be given, right? So for instance, what am I talking about? Patterns that have natural numbers, right? That are natural numbers. That's what I mean. So natural numbers are 1, 2, 3, 4. So those type of patterns, right? Sometimes you can even start from maybe 7, right? Then you'll have 7, 8, 9, 10, 11, 12. Numbers where the difference is just 1. You can even have it as 25, 26, 27, 28, right? So those type of patterns. Now here we have 1, 2, 3. But the only problem is instead of us having a 4, it's being skipped. Now we have 5, 6, 7. Then instead of us having an 8, it's skipped again. Then we have 9, 10, 11. Then instead of us having a 12, it's skipped. Then we have 13, right? So if you notice this, you will realize that the multiples of 4 are being skipped, right? So in some other cases, the multiples of 3 could be the ones that are removed, right? Some other cases, even the multiple of 6 can be removed. So we have 1, 2, 3, 4, 5. Then instead of us having a 6, it's now skipped. Then we now have 7, 8, 9, 10, 11. Then instead of having a 12, it's now skipped, right? So there's a type of pattern where all natural numbers are included, right? Up to a certain point, maybe up to 1000 or maybe up to 200. In this case, all natural numbers are included up to 101, but the multiples of 4 are being removed, right? So there's a situation where all the multiples are being all the natural numbers are being included up to a certain point, but the multiple of something is being removed. So in this case, then they'll ask you to find the sum, right? So in the Platinum textbook, it comes out in this form, but then in the exam, it comes out in the sentence form instead, what I'm going to write down just now. So that one is more likely to come out. So here is the sentence form. So it says find the sum. So it's the same question, one and the same question. This one is written in patterns form, this one in sentence form. So this one says find the sum of all natural numbers from 1 until 101 that are not divisible by 4. So it means we've got natural numbers from 1 until 101, but then the multiples of 4 are being removed because it says not divisible by 4. So whenever they say not divisible by something, you just exclude the multiple of that, right? So it says find the multiples of all natural numbers from 1 until 101 that are not divisible by 4. It's the same type of question. So how do you deal with this question? This is what we're going to do. So step number 1, you're going to find the sum of all the natural numbers up until 101, right? This also includes the 4 that has been removed. So you'll pretend as though it was not removed in step 1. You'll find the sum of all natural numbers up until 101 so that it can be a perfect arithmetic sequence, right? So that's step 1. Then step 2, you will find the sum of all the numbers that were removed, right? So the sum of all the multiple of 4 that was removed in this case, right? Here in this case, you find the sum of all natural numbers from 1 until 101. So it depends, right? So in some other cases, they can start from 7. So maybe from 7 until 500. So in step 1, you'll find the sum of natural numbers from 7 to 500, right? Then step 2, you find the sum of the numbers that were removed, right? The multiples of 6. If the multiples of 6 were removed, you find the sum of it. Here the multiples of 4 were removed, so we need to find the sum of the multiples of 4, right? So from 4 up until the last multiple of 4. The last multiple of 4 in this case is 100, right? That's just before 101. So 100 is a multiple of 4, so that's the last one. If it was the multiple of 3 that was removed, then the last multiple of 3 before 101 is 99, right? So you'll find the sum of the multiples of 3 up until 99. I'll demonstrate this stuff, right? This is just for you to memorize. You find the sum of the total when everything is added. That's number 1. Then number 2, you find the sum of the ones that was removed. Then number 3, you will subtract, right? So what you're going to do is you're going to subtract the answer of the one that was removed from the answer of the total. So basically, we get the sum of the total when everything is included. Then we get the sum of the ones that was removed. Then we subtract them. That will give us the exact answer of the sum of this thing when the multiples of 4 was removed, right? So when you have this situation where the multiple of something is deleted, what you do is you find the total as though it was not deleted, then find the sum of the one that was deleted, then remove the one that was deleted from the total. Then you'll easily have the sum of that. So let's put that in practice. So this is how we do it. Just before I continue, if you want to be tutored either online or physically, online, it doesn't matter where you are or which country you are at, you can still be tutored. So we offer cheap online lessons, and if you want to be tutored physically, we can still make an arrangement. So call or WhatsApp this number, but preferably please WhatsApp this number, and then we will take it from there. So what I do is that I tutor people 5 days a week online, and I give tests once a week so that I can check your improvements. So right now I'm finding the sum of the total when the multiples of 4 are included as well, right? So I'm finding the sum of all the natural numbers from 1 until 101. So of course this is an arithmetic sequence, right? So we're gonna say the sum of how many terms. We know that 101 terms because it's quite obvious, right? Here it's obvious in this case. So if it's not obvious, we'll now have to find the position of the last term so that we can determine the number of terms. But here we don't need to do that. We already know there's 101 terms. It's quite obvious here. So we'll say the sum of 101 terms is equals to 101 divided by 2. Now I'm using the method A plus L, right? Because I know the value of the last term. So my A is 1, my last term is 101. So here I'm gonna type, so we're gonna have, this is gonna be 55.5, but let me just leave it like that. And then here it's gonna be 102, right? Then you just type this in the calculator and you get your final answer, 5151. So that's the answer, right? So we're gonna have 5151. So that's the answer of the total when everything is included. Now we have to find the sum of the ones that are excluded, the ones that I put in red, right? So let's find the sum of that. So the pattern, of course, is 4 plus 8 plus 12 plus 16 plus dot 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 up until 100, right? So we have to find the sum of this stuff. So instead, let me just put this up there, right? So we already know the sum of the total, right? But just to avoid confusion, I'm gonna erase that one. So we know the sum of the total is 5151. That's the sum of the total when everything is included. Now the one of everything that is excluded was, here it's 4 plus 8. Okay, let me use another one. So the multiples of the ones that were removed was 4 plus 8 plus 12 plus 16, right? Plus dot 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 plus 100. So 100 is the last multiple of 4 just before 101. So you always have to find the last multiple of something that was removed just before the last value of the natural number that was given, right? So let's find the Tn formula. Why do we need the Tn formula? We need to figure out how many terms are there. We cannot find the sum without knowing how many terms are there. Here it was quite obvious. We know there's 101 terms because it's just 1, 2, 3, 4. So the value of the term in this case is the same as the term number. But here, of course, is not the same. So let's find the Tn formula. So Tn is equals to a plus n minus 1d, right? I'm just using the long cut. There is a shortcut for this. So our a is 4, our n minus 1, and our d is what? Our difference is obviously 4, multiples of 4. And then if you check this, the answer should be 4n, right? So this is the formula of the Tn, right? Tn formula. So let's find out what term number is this. So this, the value of the term, is 100. We need to find out what's that term that gives us 100. So it's going to be 100 is equals to 4n. So you divide both sides by 4 and you will get n is equals to 25. So there we have it. We know that there are 25 terms, right? That was removed from the sequence. So let's find the sum of it. So the sum of the ones that we removed is the sum of 25 terms is equals to 25 divided by 2. Then I'm going to use that formula again where it says a plus l, right? Instead of 2a plus n minus 1d. So my a is 4. My l, the value of the last term, is 100, right? So now we're going to have 25 divided by 2 into 104. Then we just need to find the answer of this stuff. So let me just type that. So that gives me 1.3. So the sum of the one that was removed is 103, right? The sum of the multiples that are removed is 103, while it's the sum of the total when it's included, right? When the multiples that we removed was included. It gives us 5151, right? So that's the sum of the total. So the sum of the total is 5151, while it's the sum of the one that was removed was 1300, right? So to get the total, we just, to get the sum of it when it's removed, right? We just need to subtract this. So that's step 3. So we're gonna say 5151 minus 1300, right? Why? Because 5151 is when everything is included, including the multiples of 4, and then 1300 is when is the sum of the multiples of 4 that were removed. So since in the original one the sum of the multiples of 4 were removed, we also have to remove it. In other words, we have to subtract it, right? So it's the sum of the total minus the sum of the ones that was removed, right? That gives you the answer of the one that was removed. So when you type this in the calculator,
so the answer to that is 3581,
right? So I'm going to show you a second example, right? Let me just show you a second example. So here is another question. Find the sum of all natural numbers from 1 to 200. Matter of fact, let me change this one. Let's say find the sum of all natural numbers from 7 to 200, right? Or 7 until 200 that are not divisible by 3. So let's just put it down in practice. So it's like we're starting from 7. We're saying 7 plus 8 plus, now instead of 9 we skip, because we want the one that are not divisible by 3, so we have to exclude all the multiples of 3. So we'll say plus 10 plus 11 plus, instead of 12 it's now plus 13, then plus dot dot dot, right, up until 200. So we're gonna say plus 200. Is 200 divisible by 3? No, it's not. If it was, then I would exclude it. Then I would put on the last number that was divisible by 3. But you really get that case where the last number is removed. The last number is usually was not divisible. So from here, we do what we did in the previous example. We find the sum of the total when the multiples of 3 is included, right? So let's find the sum of the total. So in other words, I'm saying the sum of the pattern that says 7, 8, 9, 10, 11, 12, right? 12, dot, 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 up until 200. So here we have plus 12 plus dot, 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 up until 200. So the sum of all natural numbers when the multiples of 3 has not been removed. So what we're going to do here is we need to find out first, of course, how many terms are they from 7 until 200. Well, we can use a shortcut though. We can say 200 minus 7, and 200 minus 7 will not give us the number of terms. We have to say 200 minus 7 plus 1. Remember in sigma notation, to find out the number of terms, you say top minus bottom plus 1. So you can say 200 minus 7, which is 193. Then plus 1, which is now 194. So it means there's 194 terms. But otherwise, if you don't prefer that way, let's find the nth term. So let's find the nth term of this stuff. So of course, the nth term is Tn is equals to a, which is 7 plus n minus 1d. Now, of course, our d is 1, right? So now here we're going to say Tn is equals to, when you multiply, you will realize that this is going to be n plus 6. This is the general term. So let's find out what position is 200 so that we can use it to determine the number of terms. So we want to find out which term number gives us 200. Whatever term number we find is the total number of terms when the multiples of 3 is included, right? I'm dealing with the total. So what we want to do here is, because otherwise if I was not dealing with the total, this is not an arithmetic sequence, so I cannot use this formula, right? But now I'm dealing with the total when the multiple of 9 is the multiple of 3 is included, right? So when the multiple of 3 is included, then the common difference will be 1, right? But if we look at it as this case, the common difference doesn't have a common difference. So let's look at this part. So here we have n plus 6. So we want to find out which term number gives us 200. So we're going to say 200 is equals to n plus 6. You take this to the other side, it's going to be 200 minus 6 equals to n. Then this is going to be 194 is equals to n. So it means there's 194 terms. And we get back to the answer. Remember what I did with the shortcut. We say top minus bottom. So here it's the later one minus the previous one plus 1. So 200 minus 7 is 192 plus 1 is 194. So we still end up with the same answer as 194, right? We have 194 here. So it means there are 194 terms in this sequence. So I can now find the sum in the sequence where the multiple of 3 is included, right? So what we're gonna do here is we're gonna say the sum of 194 terms is equals to 194 divided by 2 into our A is 7 plus L, which is 200, right? Remember, you can even use the long formulas, up to you, right? So if you type this in a calculator, okay, fine. Before that, 194 divided by 2, you can just type that in the calculator, right? So if you type this in the calculator, but let me just get straight to the point. Let me just get to the answer immediately. 194 divided by 2 times 207, because 200 plus 7 is obviously 207. So this is going to be 20079. You can just confirm that. So the sum of the total when the multiple of 3 is included is 20,079, right? So from here, let me just erase the question. I'm pretty sure you understand, right? Or instead of erasing the question, let me just do this. So it was 20079. So now let's find the sum of the ones that were excluded, which is the multiple of 3, right? So the multiple of 3 that is excluded. So I'm not supposed to start from 3. Can't start from 3 because this starts from 7. So 3 is before that, so I cannot start from there. I have to start from what was removed. So the next multiple of 3 that was removed is a 9, right? So I will say 9 plus 12 plus 15. So these are still multiple of 3's, right? Plus dot 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 plus. So what is the last multiple of 3 before 200? Well, if you cannot figure it out by guessing, well, you can just start by saying 200 divided by 3, then you will realize it's not divisible by 3. Then if you say 198 divided by 3, or rather 199 divided by 3, if you say 199 divided by 3, it's also not divisible by 3. Then if you say 198 divided by 3, you'll get 66. So it means that 198 is the highest number that is divisible by 3 just before 200. So the last term of the sequence will be 198, right? So then from here, we need to find the sum of this, right? So we'll say the sum of, but before that, we need to know how many terms are there in this sequence. So we have no choice but to use the Tn formula, right? So we have to use the Tn formula. So Tn is equals to A, which is 9, right? Plus n minus 1 d. Our d is 3 because it's the multiple of 3, of course, so we keep adding 3's. Then this becomes, if you just type this is going to become, I'm just skipping steps, so if you multiply as 3n, then 9 minus 3 will be 6. I'm skipping steps, right? So this is our Tn formula. So we need to find out how many terms are there in the sequence. So we're going to plug in this. The value of the last term is 198. So if we find out what is the last term, that gives us the total number of terms. So it's going to be 198 is equals to 3n plus 6. So then from here, you take this to the other side. So 198 plus 6 is 204 equals to 3n. So you divide this by 3. So 204 divided by 3. Using the calculator, I get n is equals to 68. So it means that there are 68 terms. So then I can now find the sum of the ones that were excluded, right? So let's find the sum of the ones that are excluded. So we'll say the sum of 68 terms is equals to 68 over 2 into our A, which is 9, our L, which is 198. So from here, we just get our answer straight away. So this is going to be 68 divided by 2 times 9 plus 198. So it gives us 7038, right? So that's the sum of the ones that were excluded. Now let's find the sum of this exact term, right? This exact term is where the multiples of 3 are excluded. Remember, we cannot find the sum straight because it's neither arithmetic nor geometric, not even quadratic. Matter of fact, you don't even find the sum of quadratic sequence in metric, right? Except if you find it by manually adding them. So it will give you a small number of terms. But you can ignore what I just said. So we need to find the sum of this exact term where the multiples of 3 are being removed, right? So what we'll do is we'll say the total when the multiple of 3 is included, right, minus the sum of the multiple of 3 that is being removed, right? So when you minus them, we'll get the exact answer of this. So that's step 3, right? So this is going to be 20079 minus 7038. So let's check that. So we're gonna have, so it was 20079 minus that. So the answer is gonna be 13,041. So that's our answer. That's the exact sum of the sequence, right? So remember, when they give you a sequence where a multiple of something is deleted, you have to find the total before it was deleted, and then you have to subtract the sum of the one that was deleted. You'll get the exact answer.